All right, I'm going to try to run you through a couple of sample troubleshooting examples. So as we talked in the last video, one of the bigger things to understand is the difference between switches and loads. You need to understand that troubleshooting chart, the flow chart, that's going to kind of walk you through your process, knowing what starts when, and then if it doesn't get to the next step, where to go from there. So this is going to give us a few scenarios that I'm going to go through a few of just to kind of show you how you'd approach this. Obviously, this is just from a paper, so being in front of a furnace is going to be a lot better, but at least shows you the process. So scenario number one, furnace is not heating. You're working with a direct spark ignition system and a furnace control board. You've got an inducer motor and blower motor that run continuously. So one of the first things I will point out on this, anytime you have a blower and inducer that's just on all the time and nothing else happens, more than likely it's probably out on some sort of limit or some sort of fault that it's locked itself out. And so usually that may be a time where I would try to do a hard reset, just kill the switch on the side of the furnace. Always look at your indicator lights as well. If you have those on your board, it's probably going to point you in the right direction. But let's kind of see where this takes us. And so the first thing with any call that you want to look at is, are you getting power? Do you have power at all? Like, do you have high voltage? And then do you have a call? Are you getting 24-volt power? And is that 24 volts being sent back to the board to indicate that you're actually calling for heating? And so you're going to do a quick power test on that transformer or at the board somewhere that you can get a call from red to common and see if you have 24 volts. If you have 24 volts present, then obviously you have high voltage coming to the transformer, so you don't really need to check the high voltage at that point. If you didn't, then that might be a good time to go back and check the high voltage just to make sure. Obviously, your door switch can also be a thing that comes into play. If you have the door off, you have to have that door switch pushed in to actually get the call, so don't forget that. But assuming you have your 24 volts to the board, then that board is going to send out red back to the thermostat, and then that white is going to come back on everything else. And so in this scenario, this is giving us the option. It's going to do some checking. I'm assuming we are getting a call for white. It didn't actually check that on here, which I would have checked. And so what they're doing is they're actually using one as reference. So I always say put one of your leads on something that you know, and then the other one on something that you're trying to compare to that. So remember, your meter is not just telling you that there's power, it's telling you that there's a potential difference between one point and the other. So if you read across a switch that's closed, then the voltage on one side should be the same as the voltage on the other side. So you should get 0 volts difference. So anytime you're referencing a point, you can sort of plant one lead. It doesn't have to be the black. It doesn't have to be the red. It could be either one. But plant one lead on a spot that you know. That can be a power wire, but it works better, in my opinion, if you put it on common, because common is a neutral. Now, don't get in the habit of troubleshooting to ground, because ground can give you a lot of numbers that aren't really there, that's not accurate, voltages that sort of want to go all over, and so you really want to compare it to a known point. So going to common is a good technique. And so in this case, they've planted their lead on common, and then they're going to just start checking things. And they're going to check across, in this example, they're checking across the limit. I'm assuming this is the high limit. Obviously that switch is a temperature controlled switch, and it's drawn above the line, and it's drawn normally closed, so normally it should be closed unless something goes bad. So they're going to check across that limit and see if that's what has it out. And so if you have power coming to that limit, to common, you're going to have 24 volts. And then if you're losing it on the other side, then you're going to have 0 volts. If you don't, if you still have 24, then the limit is not what has it out. You can also check across that limit if you want, and you would be looking for a voltage difference. you'd be looking for 24 to show you that it's open. But in this case, they're referencing to common. And so again, there's more than one way to do it. Just know that, whatever your system is. And so in this example, they checked across that limit and they read 0 volts on the leaving side. They had 24 volts on the entering side. And so that's going to tell them that limit switch is open. Now at that point, you'd want to actually go beyond that and say, okay, now why would the limit switch be open? Is it an airflow problem? Do I have a blower that's not firing? Do I have a filter that's dirty that needs changed? Do I have coils that need cleaned? Do I have ductwork that's collapsed or too small? Am I overfiring? And so there's probably a reason that limit's tripping, so don't just think it's a bad limit. But in this case, the limit is what has it out. Okay, we'll go through maybe one more here. So in this example, furnace does not light. So a 90% upflow furnace, that really doesn't matter. It has a hot surface ignition, so we should have a glowing igniter, and the inducer motor runs, but nothing else happens. And so that's going to probably, going through our sequence of operations, you're going to get to the point where it's going to say, does your inducer start? Yes. Does your pressure switch close? Well, at this point, we don't know that it closes because you can't just see that. But if your igniter doesn't come on, then that's usually an indication that either A, you have a bad igniter, or more than likely, it's probably a pressure switch that's not closing for some reason. So in this case, I'm assuming that's where they're going to go. So let's see. And so we've got our diagram here. You see all of our parts. We've got our inducer motor. We've got our hot surface igniter. We've got our flame sensor. All of these, again, coming off of the board. We've got our pressure switch. That pressure switch is coming out and then going right back. And so that pressure switch signal is being sent to the switch, through the switch, back out, and back to the board. Once the board gets that signal, then it knows that the inducer must be working, the draft is good, we have fresh air, we're not stopped up, and the pressure switch isn't stuck open or stuck closed even. That'll cause a fault as well. So it's sending a call out, and then if it receives that call back, then it knows to proceed to the next point. And so what we're going to do here is we're going to actually check that out. So again, in this example, they're referencing to common, which, like we said, is fine, a known point. And so common on one side, I'm reading 24. Common on the other side, I'm reading 24 as well, which tells me that the pressure switch is actually closed. And so at this point, they're going to go to the hot surface igniter because the pressure switch is closed, so that should be making it. You're going to go to the hot surface igniter and you're going to test. In this case, they're testing to their neutral, and then they're testing to the wire that's going out from the board, and so seeing if it's actually getting a call. Now you could also maybe check that closer to the igniter or check it at the plug. A lot of times those igniters will have a plug closer to it, and you can see if you're getting power that way. If it is getting power, then that's a good indication that it's, if the pressure switch is closed, then it's calling for the igniter. That's why you're getting power intermittently when it's calling. So if the igniter is still not glowing, then more than likely the igniter is bad. And so at that point, you can take the igniter out if you can get it out easily and do a visual inspection. Another thing you can do is just unplug it if it has a plug, or disconnect it from the board and do an ohm test across it, because any hot surface igniter should read resistance. And so if you do not read resistance, so in this case they're doing a resistance test and they're reading OL across that, which means open loop, getting no call, or getting no continuity. So 0 would be a short. That's not good either, because this is a load, so it's not a switch. So it should read some number. It should read resistance. So the fact that they're reading OL tells us that that hot surface igniter is broken somewhere and would need to be replaced. And so that's why, back to the original scenario, that's why the inducer is running, nothing is happening. As I said, a lot of times I would check the pressure switch first because that seems to be more common in my experience, but it could just as likely be the next step, which would be that the hot surface igniter has it out. Now, if it were the pressure switch in this example, then I would be reading 24 coming in and 0 coming out of that pressure switch. And then at that point, you'd want to actually go to the pressure switch, make sure that everything's plugged up right, but then you're going to check your inducer. You're going to check your vent pipes, make sure that nothing's in those pipes, that there's not a bird's nest or um, snow or water buildup or anything in that, and even in your inducer chamber itself. If you get anything in there that's going to stop up airflow for that draft, then that's not going to allow that pressure switch to stop or to close. And then even the hose that goes to the switch, sometimes they can get blocked up with a piece of dirt or something because they're pretty small, or they can get dry rotted or get a crack or a hole or have a leak to where they're not allowing that suction to stay. And so if the pressure switch isn't closing, don't go change the pressure switch. More than likely, the pressure switch is telling you there's a problem. It's not telling you there's a bad pressure switch. Not saying that there can't be a bad pressure switch, but more than likely it's doing its job, not needing replaced. So just a couple of common examples, things you might run into. So hopefully that helps get you started.